Good morning. Good morning. Good morning. Good morning. Good morning. So, you are practicing the problems of unit and dimension. Yes, sir. Good. So today at least dimension part and unit part will complete. That is a weekend syllabus also. Okay, so in the last, I think I discussed like when we are changing the fundamental system, like different derived quantity we are taking as a fundamental quantity, then what is the dimension of like fundamental quantity, mass, time, then they will be derived. If we are taking any derived as a fundamental, then our fundamental quantity will be derived. So some question I discussed and some I gave, you will do by own. Are you remember or not? Okay, and I said the one method, method 3 means if you are not getting, then you can go to the method 3. By that, whatever the system they are changing, according to that, you can write the proportionality relation and you will get the variables. Only you have to practice how to solve linear equation 2 variable, linear equation 3 variable. Okay. So, now listen, like suppose if I am asking sine theta, y is equal to sine x or y is equal to sine theta. If I ask what is the dimension of x, what is the x represent here? If I am writing y is equal to sine x, what x represent here? Y is equal to sine x, what x represent here? So x represent what? Angle, okay. And what is the dimension of the angle? Angle is the dimensionless. It means if I am saying the sine x, so x is what? Dimensionless, okay. Now sine x, what is the dimension of sine x? So sine x will also give the pure number, like sine 30 degrees is equal to 1 by 2. So sine x is also the dimensionless. So what I can say in this equation, y is equal to sine x, I can say x is dimensionless as well as y is dimensionless. This everybody got or not? I think this I have not discussed. Are you say yes or no? Okay, so here what I said, y is equal to sine x means we can think like sine x is the one machine in that. What is the input you will give? You will give the input is what? Dimensionless. And what is the output of the sine x? It will also give the dimensionless. Means it will take the dimensionless quantity, input will be dimensionless quantity and output will be also what? Dimensionless. Okay. So like this relation if I am writing y is equal to sine x. So what is the dimension of x? Dimensionless. What is the dimension of y? Dimensionless. This everybody got? Same way if I am saying the e to the power x, okay, e to the power x, what is this? What is the e here? What is the e here? E is the Euler's constant. Its value is the 2.7 approx. So E is the Euler's constant and power function is called the exponential function. Power function is called the exponential function. Like e to the power x. E is the exponential, not the e is the not exponential. E to the power x is the exponential function. Okay. So any power function like I am writing e to the power x, a to the power x, 2 to the power x, all are the exponential function. E is not exponential. E is the Euler's constant. Okay. So any power function that we are calling as exponential function. Power exponent means what? Power. So any power function is the exponential. Okay, like either I'm writing e to the power x, a to the power x, or 2 to the power x. Okay, here if suppose just take the example 2 to the power x, can I write there is a meaningful 2 to the power 2 kg? There is a meaning of that. This relation 2 to the power 2 kg seems meaningful. Tell fast. No. Yeah, because to number to the power unit, what is the meaning of that? So it means what? When we are writing the exponential function, then power will not have any dimension. Power will not have any dimension. This everybody got? Means here I can say what? X, 2 to the power x, or any constant to the power x if I am writing. So x must be dimensionless, means power must be dimensionless. Okay, this everybody got? Now, now power is dimensionless. So if I am asking 2 to the power 2, so when power is the number, pure number, then 2 to the power 2 will also give the pure number. It means in this case what I can say, in the exponential function, power is dimensionless, as well as exponential function is also dimensionless. Like y is equal to e to the power x. Y is equal to e to the power x. What is the dimension of x? Dimension is what? X is the dimensionless. X is the dimensionless. Why? Because it is a power. What is the dimension of y? Y is also dimensionless. This everybody got or not? Same like a trigonometric. So we can say the exponential function is the machine in which input we are taking as a dimensionless, output also we are getting the dimensionless. Got it? Completed. Then I can say what? Y is dimensionless as well as x is also dimensionless. Same way we can say for the log also. Okay, we can say for log x is the dimensionless as well as log x is also dimensionless. So these functions we have to remember, like trigonometric function, exponential function, log function, their input as well as output will be dimensionless. This everybody got or not? So trigonometric function like sin x, cos x, exponential function, like e to the power x, log, their input means what? X, their input as well as output is dimensionless. Okay, so we can say trigonometric function, exponential function, log function means their input. The input is what? X as well as their output. Output is what? Sin x, cos x, e to the power x, that is the output. Then we can say both will be what? Dimensionless. Everybody got? Okay, so one small example I am asking. In the wave, this equation you will learn. What is the dimension of the ABC? Dimension of ABC. What is the dimension of A, B and C? So here first thing, homogeneity, everybody know. Here BX and CT we are subtracting. Okay, so dimension of BX must be dimension of CT. Okay, Bx and ct we are subtracting. We can add, subtract or equate only when they have the same dimension. Yes or no? So bx and ct we are subtracting. So dimension of bx is equal to dimension of ct. Okay. And bx and ct, it is the input of the trigonometric function sine. It is the input of the sine. Okay. It means they should be dimensionless. Basically, they are representing the angle. Like bx is suppose pi by 2, ct is pi by 6. So both are representing the angle. Angle minus angle, don't say dimensionless. Angle minus angle, what you will get? Angle. So bx is the angle, ct is the angle, and we know that angle is the dimensionless. So I can say what? Bx is dimensionless as well as ct is dimensionless. This everybody got or not? Like this sine of bx minus ct, it is the whole is the angle. Okay, whole is the angle. So bx and ct we are subtracting. It means bx dimension and ct dimension are equal. And input of the sine is the angle. That's why dimension of bx and dimension of ct are same. That what? They are dimensionless. Understood or not? Don't say sir angle minus angle is the dimensionless. Angle minus angle is the angle. We are not dealing with a number like you are taking one number angle, other number angle, angle minus angle is the 0. We are dealing with the units, dimension. So angle minus angle, what is the output? You will get angle. Everybody got or not? Up to this okay? Say fast. Now after that, if I am asking this dimension, what is the dimension of this? What is the dimension of sine of bx minus ct? So sine of angle, any angle, it will be dimensionless. So sine of any angle is dimensionless. So this is also what? Dimensionless. Okay. Now only a remain here. Only a is there. So means from the homogeneity, what we can say? Dimension of y must be same as dimension of a. Or everybody got or not? So dimension of y must be same as a. Okay. And bx and ct dimension are same. Basically what? They are dimensionless. So bx, ct dimensionless and a has the dimension of y. Y is what? Displacement. So what is the displacement? L. Okay. Now we can write here. So bx and ct are dimensionless. This everybody got? And one more thing. This I said in the last class also, like when we are dividing the same quantity, same physical quantity, like velocity upon velocity, what I will get? Suppose I am dividing velocity upon velocity or speed upon speed. I am dividing speed upon speed. Then what you will get? Speed upon speed. What you will get? Dimension. I'm not saying the number. I'm not talking about the number. Means any speed 5 meter per second upon 3 meter per second. So meter per second cancel out. You will get the only magnitude 5 by 3. Okay. So means when we are dividing the same quantity, when we are dividing the same physical quantity, then resultant we will get dimensionless. This note also you have written last class. Okay. And when we are multiplying the reverse reciprocal quantity, like one is suppose meter, so other is the meter inverse, then by multiplying them you will get dimensionless. Okay, this I said in last class. One more thing, when anything you are getting dimensionless, then in the form of equation how you will write? Like bx, I am getting the bx is dimensionless. Then how I will write this bx as a dimensionless? How I will get the dimension of b? So what we can write, if bx is dimensionless, then I can say dimension of b into dimension of x. Bx dimensionless means dimension of b into dimension of x. When you are writing dimensionless, then equate with 1. 1 is not a number. It is like it will represent the reciprocal or whatever accordingly you can write. Okay. So means here I am writing what? 1. Why 1? Because they are dimensionless. So when we multiply the two opposite quantity like meter per second upon meter per second. I'm not talking about the magnitude. Meter per second upon meter per second. What you will get? 1. Everybody getting or not? So this is not a number. It is just representing when we divide the same quantity, we will get 1. This everybody got or not? So when anything you are getting dimensionless and you want to write in the form of equation, then all dimension, this dimension upon this dimension, that is equal to what? 1. In the form of equation you will write like this. Okay. Now dimension of B, what I got? Dimension of B into dimension of X is what? L, that is equal to what? 1. Now dimension of B, what we got? 1 by L, that is equal to what? L minus 1. Okay. Now similarly we can say for CT. CT is also what? Dimensionless. So CT is dimensionless, means dimension of C into dimension of T, that is a T. It is equal to what? Dimensionless means 1. Then dimension of C, what I got? Dimension of C is equal to 1 by T. 1 by T is what? T minus 1. So dimension of C, what we got? T minus 1. Okay. And if I'm asking the A dimension, then I can say what? Dimension of Y, A is equal to dimension of Y, and Y dimension is what? L. Okay. Completed. Another problem. Suppose I have given the pressure P is equal to alpha into e to the power minus beta T by alpha. Find dimension of alpha and beta. Okay. So here you can see I have given the exponential function. So what we can say, e to the power something, that something is a power. Power must be dimensionless. Okay. So what is the power here? Beta T by alpha. Beta T by alpha. So one thing I can say, beta T by alpha is dimensionless. Okay. Exponential input as well as output is dimensionless. So beta T by alpha is dimensionless. Okay. And what is the dimension of this? What is the dimension of this? It is also dimensionless. It is also dimensionless. Then one thing I can say, dimension of pressure is same as dimension of alpha. This everybody got or not? Dimension of alpha is equal to dimension of pressure. And beta T by alpha must be dimensionless. Okay. Then beta T by alpha is dimensionless. And second thing what I can say, dimension of alpha is equal to dimension of pressure. Okay. Now pressure dimension we know ml minus 1, ml minus 1, T minus 2. So pressure dimension is this. So dimension of alpha you got. Okay. Now I will come to the beta. Here two quantity I am multiplying and then one is dividing. So I can say here dimension of beta into dimension of T. Dimension of T is what? T. Upon dimension of alpha. Dimension of alpha. Alpha dimension what I got? ml minus 1, T minus 2. It is a dimensionless, then I can write as a 1. It is a dimensionless, then I can write as a 1. Otherwise here you can write first dimension of alpha. Choice is your dimension of alpha. Now cross multiplying, then what I will get? Dimension of beta into T, that is equal to dimension of alpha. Dimension of alpha. Alpha dimension what we got? ml minus 1, T minus 2. Okay. Now what is the dimension of beta? Dimension of beta what we got? T you will divide. So ml minus 1, T minus 3. I think everybody got also. Yes. ml minus 1, T minus 3. Completed. Okay. So these are like dimension, how to find the dimension of the different quantity by the formula and all. Now some application of the dimension. So sometime in the, I have seen in the JE also, JE main, JE advanced and NEET also, sometimes they will ask the question and they will ask in the terms of data, they will give in the terms of symbol. Like quantities, they will not give the numerical value. They will give the symbol of the quantities, like pressure is the P, this is the this. Then they will ask like what is the temperature of the body, what is after what time the velocity will be like this. Means they will give the symbol and they will ask any quantity. Okay. Maybe solving the problem by the symbol, if you will see, it will be complicated, it will be difficult. But sometime what will happen, like suppose they are asking the time and different option they given in the terms of symbol. So if you will check the option, then maybe it is possible that only one option will have the dimension of time. Only one option will have dimension of time. Then means without solving, you can say that is the answer. Okay, so sometimes this trick also work. Means if you are unable to think that how to start, or maybe you're thinking calculation is lengthy, then you can, whatever the quantity number if they given, the number how we can identify means what is the answer, like 5, 3, 4, 2 options are there, then we cannot say. But when they are using symbol and the option are also in the symbol of the physical quantity, then what they are asking, according to that, if you check the dimension, definitely you will get the answer. Like this year also surface tension question they given. Okay, that was the toughest question of the NEET 2025. Then if you, whatever they are asking, if you check the option, two option was the what does not have the dimension what they are asking. Okay, so two option dimension was not matching, so only the two you have to take the risk, or you can say that two you have to check. Okay, so dimension is the one of the approach we can say. Now what is the application of dimension? One is what, by the dimensional analysis, we can verify any physical equation. Okay, so dimension technique we use to verify any physical equation. So many formula in the physics we have learned, we can use the dimension technique to verify them. Okay, so we can verify physical equation by dimensional analysis. Okay, that is the one application. Now listen, if suppose I am saying any equation is dimensionally correct, then physically, or we can say that equation may or may not be correct. If any equation passes the dimension test, means on the basis of dimension that equation is correct. Okay, what you got on the basis of dimension that equation is correct, then it may or may not be correct. Why? Because by the dimension we cannot verify the constant. Like I am giving the example, S is equal to ut plus half at square. Okay, in the place of half I am writing suppose 2at square. Then here 2 is there or half is there, we cannot verify that by using the dimension. So if any equation pass the dimension test, then it may or may not be correct. Because constant trigonometric function, exponential function, these function we cannot verify by using dimension. Okay, that is the one thing. But if any equation fail the dimension test, on the basis of dimension it is incorrect, then we can say definitely it will be incorrect. So what I said, if any physical equation pass the dimension test, then it may or may not be correct, because constant and some function we cannot verify by using dimension. But if any equation fail the dimension test, if it does not satisfy the dimension condition, then we can say definitely it will be incorrect. This everybody got or not? So if equation is dimensionally correct, then it may or may not be right. But if any equation is dimensionally incorrect, then it will be wrong. Okay, so if it failed the dimension test, then it means it is a wrong equation, we can say. Everybody got? Okay. Suppose I am saying S is equal to, up to this okay? S is equal to UT plus half a t cube. Okay, this I have written the equation S is equal to UT plus half a t cube. Okay, you know this equation, that's why you can directly say that it is incorrect. Okay, but if you are checking by the dimension, suppose you don't know the equation and you are verifying by the dimension, then what you will do, according to the homogeneity dimension, here two quantity we are adding, UT and AT cube. Half is a constant, UT and AT cube we are adding. Okay, so their dimension of UT must be same as dimension of AT cube, and they are equated with S, so their dimension must be same as S. Okay, so what is the S dimension? I can say S dimension is the what? L. Okay, what is the UT dimension? U, I can say LT minus 1. And T is what? T. Then what I got? L. Okay, that is okay. Now AT cube dimension, AT cube I can say acceleration is LT minus 2. T cube is what? T cube. Then what I got? LT. Now they fail homogeneity. Okay, then it means I can say what? Left hand dimension is not equal to the right hand dimension, or they fail the dimension test. That's why this equation is incorrect. So equation is incorrect. Completed. Now one more example. Like this, any equation we can give. So here 3 I gave. I'm saying which equation is dimensionally correct. Fourth option I'm giving none. So here in this type of problem, when they given trigonometric exponential, then we have to check for trigonometric function also, as well as whole equation also. Okay. So if I see the first one, first equation. So first thing, if it failed this directly, like I can say sine theta dimension is what? It is a dimensionless. Okay. So first I will check for this. Dimension of y must be same as dimension here. Okay. A is the amplitude. Later you will learn here. A is the amplitude. Okay. So y dimension of whatever here sine, it is a dimensionless. So dimension of y must be same as a by t. Okay. But we know that y dimension is L and a by t dimension is what? L by t. That is LT minus 1. So here LHD is what? Left hand dimension is L. And what is the right hand dimension? L by t. So it failed that test. LHD is not equal to RHD. So no need to go inside. No need to check inside. Directly I can say this is the incorrect equation. This is the incorrect equation. Why? Its dimension is not same as this dimension. Everybody got? Okay. Now second one. First when you check this. So now y is the L and a is the what? L. So dimension of y and dimension of a are same. That is okay. Means on that basis it is the correct. But here we have to check the inside the sign, because maybe that they can give correct, but inside is not satisfying the angle condition. So inside also we have to check. Okay. So y dimension means L dimension, a dimension, L dimension. That is okay. Now I will come check for the angle. Lambda x. Lambda x is what? Lambda is the wavelength. Wavelength means length. Dimension is what? L. X dimension is what? L. L square. But it should be dimensionless. It should be dimensionless. So on that basis, it is incorrect. Other way also you can say lambda x means L square. T means time. Now I am subtracting the two different quantity. So homogeneity is getting failed. Okay. It means on that basis I can say this is the incorrect. This is not possible. So this equation is incorrect. So here it is satisfying, but angle condition it is not satisfying. That's why it is incorrect. Are everybody got or not? Okay. Third one, okay. So first, this is the dimensionless. Okay, this is the dimensionless. So dimension of L, y is the L, a is the L. That is okay. Okay. Now come inside. Here x by lambda, L upon L dimensionless. That is okay. L upon L is the dimensionless. But 1 upon t, I am subtracting with 1 upon t. What is the dimension of this? T minus 1. So dimensionless, I am subtracting. Dimensionless minus 1 by t. Is it meaningful? Here x by lambda dimensionless. That is right. It is angle x by lambda is dimensionless. And I am subtracting 1 by t. What is the dimension of 1 by t? What is the dimension of 1 by t? T minus 1. Okay. So here I am subtracting dimensionless minus t minus 1. It is meaningful. Is it meaningful? No, Nalayak. Like 1 minus t, 1 minus per second. One is the what? Dimensionless quantity. So other also has to be dimensionless. Na? 1 by t, what is the dimension? T minus 1. But it is representing the angle. It should be dimensionless, and it failed the dimension test also. It failed the dimension test also. T I took common. Faizan. T I took common. If I am taking t common, then this t will get multiplied with this also. Okay. So if you are going through that, if you are multiplying with t, then you will say what? Tx by lambda minus small t by capital T. Okay. Then its dimension will come what? X by lambda dimensionless, its dimension will be t. And small t by capital T, what is the dimension? Dimensionless. So no need to multiply. That just I have given to confuse only. Small t, whatever I gave outside the bracket, it will get multiplied inside with the both term. Na? So directly check this only. Why I have to take the t inside and then we have to check? Because t is multiplying with this as well as this. Okay. So x by lambda dimensionless. 1 by t, what is the dimension? Dimensionless. 1 by t, 1 by t, what is the dimension? T minus 1. So angle must be dimensionless. It means it is failed the angle test. It is failed the homogeneity test. Homogeneity test, why? It is a dimensionless. It is a t minus 1. Okay. If you want to check for the t, multiply with t, you will get this. Now tx by lambda dimension is what? T. T by t, what is the dimension? Dimensionless. Now t I am subtracting with dimensionless, then also it is incorrect. So on the basis of the homogeneity, on the basis of the angle test, it failed. Okay, so what is the answer? Fourth one. None. Any option confusion, then you can say. Completed. Okay. So means by using the dimension we can verify the any physical equation dimensionally. Okay, if it is a dimensionally incorrect, then we can say it is an incorrect equation. If it is a correct, then it may or may not be correct. Okay, completed. But here in this case, what is the limitation? Means limitation of dimension. Like in this method, when we are checking any equation dimensionally, we cannot verify the constant. We cannot verify the constant. Like if I am writing s is equal to ut plus 2at square, okay, then this equation is dimensionally correct. This equation is dimensionally correct because ut dimension, at square dimension are same and they are same as the s dimension. So on the basis of dimension, it is a correct. But we know that it is a wrong equation because there is a half at square is there. So one limitation is what? We cannot verify the constant. We cannot verify the constant by the dimensional analysis. We cannot verify what is the constant here. 3 is there, half is there, 2 is there. We cannot verify. So constant cannot verify by using this. So that is the one limitation of this. Okay. Everybody got? Second thing, suppose I am saying dimensionally this equation is correct or not. First say fast. Fast. Dimensionally this equation is correct or not. Dimensionally this equation is correct or not. Dimensionally, yes. This equation is correct. Why? One thing, this is dimensionless, then dimension of y and dimension of a are same, LL. Then I will come inside t by t, dimensionless, x by lambda, dimensionless, and subtracting means they are verifying the all condition of the dimension. It means this equation is the dimensionally correct. But is it right equation? No. Why? Because actual equation of the wave, later we will learn also, y is equal to a sine omega t minus kx, like that, or a cos. Means in the place of tan, either sine is there or cos is there. But here I have written the tan, but also we are verifying this, it is the correct. Okay. Everybody getting or not? So means what? What is the limitation here? I can verify dimensionally. Dimensionally it is satisfying the equation. But there is a tan, or there is a sine, or there is a cos, or there is a log. I don't know. Why? Because that function we cannot verify by using dimension. Sine is there, cos is there, tan is there, that we can verify? No. Because sine theta, cos theta, tan theta, they don't have the dimension. How I know that there is, in the equation there is a sine, or there is a cos, or there is a tan? Okay, so that is another limitation. Means one constant we cannot verify by using dimension. Second thing, what? If equation contain, any equation contain the trigonometric function, exponential function, log function, then those functions we cannot verify by using dimension. Here e is there, here log is there, here sine is there, here cos is there, here tan is there. We cannot verify. Everybody got or not? Okay. So what I said, constants we cannot verify by using dimension. Second thing, any equation contain the trigonometric function, log function, exponential function, those equations we cannot verify by using dimension. Got it? Completed? Okay. Now application 2. So you will write now. Everybody has written that point. Means constant we cannot verify by using dimension. And if the equation contain the trigonometric function, log function, exponential function, so these functions we cannot verify by using dimension. Like in the chemistry, in the chemical kinetics, this relation you will learn. Earlier in the radioactivity it was there. Like this type of n is equal to n naught into e to the power minus lambda t. Can I verify this by dimension? No, because exponential does not have dimension. E to the power minus lambda t is there. What is the e to the power? That we don't know. Okay, so this equation, like we can, this function we cannot verify by using dimension. Exponential is there, log lambda t is there, I don't know. Dimensionally it is correct. N is a number, here also it is a number. Dimensionally it is correct. But here exponential is there, here log is there, that I cannot say. Okay. Like in the place of this, if I am writing n is equal to n naught log of something. Okay. Lambda by t or something. So maybe dimensionally it is verifying. Okay. Or here I write lambda t. Then also you will say, sir, it is a dimensionally correct equation because log does not have dimension. Then n dimension number. Okay. So dimensionally it is correct, but it is not the correct equation. So which equation contain the log, exponential, all we cannot verify by using dimension. Now second application is what? That is a method 3. What I said for the changing the fundamental system. Basically that is in the application 2 we are going to use that. So what is the application? Next application. Sometime maybe we don't have the formula. We don't know like what is the actual formula of the quantity. But we need the proportionality. Means if I am changing this quantity, what is the effect on this quantity? Like suppose we don't have the formula of the force. But we want to check that if we are changing the mass of the body, then how the force is changing, how the force is getting affected. So for that, we can use the dimensional analysis to get the proportional relation between the different quantities. Okay. So what is the application 2? We can establish the relation between the different physical quantity. By using dimension, we can establish the relation between different physical quantity. Okay. Like one example is what? Einstein equation E is equal to mc square. There is no proof of that. Okay. Einstein equation, there is no proof. That's why in between, sometime what will happen in the newspaper. Few years back also, now also sometime it is coming in the newspaper or somebody in the social networking site, you will see people claim on Einstein equation. Okay. After some time, what will happen? They will fail to prove it, to fail it. Okay. Einstein equation does not have proof. Einstein equation does not have proof. Okay, so that's why in between somebody is saying it is a wrong and they are trying to fail it, but nobody failed up to now. But one thing I can say, Einstein equation is dimensionally correct. E is equal to mc square. If you will check the dimension, it is a dimensionally correct equation. Okay, everybody got or not? So sometime what, we don't know the exact formula, but at least we can say the proportionality and all by using the dimensional analysis. Everybody got? And solution of this type of problem will be same as the method 3 what I said in the last class. Okay, so application 2 is what we can okay, so we can establish the relation between different physical quantity. Okay, what we will do for that? For this, we should know that the quantity depends upon which other physical quantity. Like suppose I am saying force, so means any force. If I am talking about gravitational force or the force formula for the mass into acceleration, or I am saying the centripetal force, means this force depends upon which other quantities. That we should know. Okay, so for example, if I am saying if centripetal force F depends upon mass of body m, speed v, and radius of circular path r, then find relation between them. Okay, so like centripetal force F, I said it depends upon the mass of the body m, speed v, and the radius r. Then we have to find the relation between them. Okay, same way like I said, momentum, time, and area. I am taking fundamental. What is the dimension of the pressure and all. Similar type of problem here. I am saying here force depends upon the mass, velocity, and radius of the circular path r. But how the force depends upon the mass, that I don't know. Maybe everybody know the formula of the centripetal force, but suppose that formula we don't know. Okay, then centripetal force, how it depends upon the mass, we don't know. It is a directly proportional to the mass, it is a directly proportional to the m square, it is a inversely proportional to the m, that we don't know. Okay, similarly we don't know how the force depends upon the speed. It is a directly proportional to speed, inversely proportional to speed, inversely proportional to speed square, that we don't know. Okay, but they have given force depends upon these three quantity: mass, speed, and radius r. But how it depends, we don't know. So what we will do, I can say what force is directly proportional to three quantities are there. So mass, what is the power, I don't know. So I will take the power is variable, m to the power a. Similarly, speed to the power b. And the third quantity is r to the power c. So what I write, I don't know the power, how it depends upon the mvr. So what I am doing, I am taking the variable power a, b, and c. Now our aim is what? We have to find the a, b, and c. Okay, now this is the relation. Proportionality constant you can put also. So now LHD, left hand dimension, what I can say? Left hand side we have the force. Force dimension is mlt minus 2. Okay. Then RHD, what I can say? RHD m to the power a. So m directly I can write m to the power a. Okay. Velocity, speed, what is the dimension? LT minus 1 whole to the power b. And the radius means what? L to the power c. This everybody got. Now total m power, what I got? Total m power we have a only. L power, what I got? L to the power b plus c. And the t to the power, what I got? T to the power minus b. Okay, RHD I got this. Now if I compare, then here m to the power a, here m to the power 1. RHD is equal to LHD. For the equation, this has to satisfy homogeneity. Okay. Now I can say what? A is equal to 1. Okay. T to the power, here minus b, here minus 2. Then I can say what? Minus b is equal to minus 2. Minus minus cancel out. What is the b I got? 2. So A I got 1, b I got 2. Now for the L is what? B plus c. B plus c is equal to how much L here? 1. So I will put here what? 1. B I got the 2. So C what I got? Minus 1. Now I got the three variable A, B, and C. Everybody got or not? Now then what I can say? Now force is directly proportional to m to the power a. M to the power a means a value what I got? 1. V to the power b. What is the b value I got? 2. And r to the power c. C value what I am getting? Minus 1. R to the power minus 1 I can write in the denominator. Then what I got? F directly proportional to mv square by r. Completed. So by this way, any question they are asking, only they will give dependency, like this quantity depends upon which quantities, okay, and by using that you can find the relation between them. This everybody got or not? Okay. So many question is there now everywhere in the material you can get. Also one more I can discuss. I will see in the last, if time will be there, then one question I will give, you can solve. Otherwise you can go through any book, you will get the question based on that. Now next thing, what is the limitation? What is the like in which case we cannot apply this method to get the relation between the different quantities? Suppose I am writing just now, I write the relation. You everybody know also S is equal to UT plus half AT square. Okay. Or suppose I am saying kinetic energy of rolling body. Kinetic energy of rolling body is the half mv square plus half I omega square. Okay. So like this type of formula we have, v square is equal to u square plus 2as. So in this, suppose I am giving the relation, a body moving with constant acceleration, its displacement depends upon initial velocity u, acceleration a, time t. Suppose I gave this relation, a body moving with constant acceleration, its displacement s depends upon u, initial velocity u, time t, and acceleration a. Find the relation between them. Okay, so what we will do? We will do what? S depends upon initial velocity u, then u to the power a, then acceleration to the power b, time to the power c. Like this only we will do. So what will happen? Maybe some quantity will come in the product, some will be in the denominator. But how we know that in the actual formula plus sign is there, minus sign is there? How I will get plus sign and minus sign in between? Are you getting what I am saying? Like suppose here, when I am writing the S directly proportional to u to the power a to the power b, t to the power c, then if I apply the dimension and all, then can we get the relation like ut plus something? No. Why? Because here I write all quantity in the product. So maybe according to the value of ABC, some will come in the numerator, some will come in the denominator. But we will not get in plus between, we will not get the minus in between. Everybody getting or not? It same way like the kinetic energy I am saying, half mv square plus half I omega square. In that, if I will say kinetic energy of rolling body depends upon mass of the body, speed of the body, moment of inertia of the body, like this. Okay, then you will write all in the product. So you will get only one term after solving. But here what is the energy formula? Half mv square plus half I omega square. So means how I will get in plus in between by this method? We cannot get. So it means what? We cannot derive the relation, or we cannot get the relation between the different physical quantity. We cannot get the formula that contain the more than one term. Which formula contain more than one term? Like here, ut plus half at square, two terms are there. Half mv square plus half I omega square, two terms are there. So if any equation contain more than one term, that relation we cannot derive by using dimension. Everybody got or not? Understood? So means if any equation contain more than one term, that we cannot derive by using dimensional analysis. Okay, this everybody got. Second thing, if any equation contain the exponential, log, same like three function what I said, exponential, log, or the trigonometric function. So same way, like if I write the wave equation y is equal to a sine omega t minus kx, like this. Okay. So if I am saying that displacement of the particle in the wave depends upon the amplitude, omega, time, like this I said, then find the relation between the displacement and this quantity. Then what you will do, y directly proportional to a to the power this, omega to the power this, k to the power this. In between, sine is there, cos is there, tan is there, e to the power is there, log is there, that we don't know. If we don't know the equation, how I know that equation contain the sine, equation contain the cos, or equation contain the exponential? Why? This function we cannot verify by using dimension. So what I can say, if the equation contain the trigonometric function, exponential function, log function, so those function we cannot get by using the dimension. It means those equation we cannot derive by using the dimensional analysis. Okay. So if the equation contain the trigonometric function, log function, exponential function, so these equation cannot derive by using dimensional analysis. Like I write the one equation, n is equal to n naught into e to the power minus lambda t. I cannot derive by using dimension, because how I know that e to the power is there in this function? Everybody got? Okay. So this is all about the dimension. Now after that, all dimension question means dimension related question you can try, but some quantity that you don't know right now, maybe because you forget the quantities, what is the self inductance, what is the permeability. Permeability I said in the class also, like so many quantities are there that you don't know right now. Okay, what is the time constant, what inductance, RC circuit, capacitance formula, maybe you forget. Those we are not expecting right now. As you will learn the chapters, you will learn the dimension. Okay, and in the last, in the revision, after completing all chapter, then few questions we will directly do on by using all those quantity. Okay, so right now basic quantity, whatever I said, you have to practice, and all question based on their dimension. Okay. Now, last small thing, change of unit, change of system of unit. When we are going from the one system to the other system, then what is the effect on the units and what is the effect on the magnitude? So like suppose I am saying I have the 1 kg sugar. I said already in the basic mathematics also, and in the beginning this chapter also, when we are going like converting the any quantity small unit to large unit, when we are converting a small unit to large unit, then what will happen, magnitude of the unit in the system, when you are going from one system to another system, in which unit is you are going from a small unit to large unit, so unit become large, so magnitude will decrease in that unit, in that system. So when we are changing any physical quantity, we are changing from one system of unit to the other system of unit. So if I am going from the small unit to the large unit, then magnitude will decrease from large magnitude to the small. So unit large, small to large, magnitude will decrease. Okay, like that way we say the nu is equal to constant. Other way, like you have the 1 kg sugar. Now I am saying convert this into the gram. 1 kg sugar you have, convert this into the gram. So we know that 1 kg is equal to 1000 gram. 1 kg is equal to 1000 gram. So kg to gram kg is the large unit, gram is the small unit. So I am going from the large unit to small unit. So unit is decreasing, so magnitude has to increase. Now you can see 1 kg, what is the magnitude here? 1. And 1000 gram, what is the magnitude here? 1000. So when you change the large unit to small unit, then magnitude changes from small to large. Everybody got or not? So means unit increasing, magnitude will decrease. Okay, but amount, we can say amount will be constant, amount of the quantity will be constant. Like 1 kg sugar is a 1 kg sugar, whether I am writing in the 1000 gram or I am writing the 1 kg, that sugar is the constant, total amount is constant. But when we are changing the unit according to the system of unit, magnitude will also change. Okay, so for that's why we have learned this relation, Nu is equal to constant. Nu is equal to constant. What is the N here? N is the magnitude of quantity in given system of unit. What I can say, N is what? Magnitude of the physical quantity in a given system of unit. And what is the U? U is the unit of physical quantity. Okay, from this I can say what means Nu constant means bigger unit, smaller magnitude, smaller unit, bigger magnitude. Then I can say what? N is inversely proportional to U. N is inversely proportional to U. Okay, for two system, suppose I am saying I am going from one system to another system, so we can say what? For two system of unit, we will use the relation what? N1 U1 is equal to N2 U2. N1 U1 is equal to N2 U2. Completed. How are you, sir? I am good. How are you? Okay, so one system of unit to other system of unit you want to go, like they are saying we have the one work or force in this unit, this is the magnitude, what is the value in this? Okay, then it means we have to use the change of unit formula, like N1 U1 is equal to N2 U2. What is the N1, what is the N2? So listen first, when you are going to apply this relation N1 U1 is equal to N2 U2, first thing you have to decide by on that which system you are going to take 1, which system you are going to take 2. Reason is what? Our habit is what? Like 1 and 2 is there. First data, all first data we will take for the first system. Second data we will take for, because we are not reading the question carefully. Like first, suppose in the ideal gas equation you will learn P1 V1 is equal to P2 V2. So first pressure P1, second pressure P2, first volume V1, second volume. Without reading the question properly, you are taking the random, like first pressure what they given, that is a P1. So when you are going to apply this type of relation, first you have to decide which I am going to take as a 1, which system I am going to take as a 2. Okay, after that, like which system you have taken 1, their magnitude you will take N1, their unit you will take U1. Which system is the you are taking 2, their magnitude is the N2, their unit you will take U2. One thing. Second thing, here I am writing the U1 U2. We are writing the unit. Sometimes they will give SI unit, like Newton, suppose they given. Okay, so by writing the Newton, I cannot get the relation between the quantities, units, because Newton is the SI unit. Okay, so when you are applying this relation, so first you have to write the dimension of the quantity, which quantity they are talking about. First write its dimension. Okay, like Newton, force I am saying. So force is what? SI unit is Newton. But what is the dimension of force? MLT minus 2. What is the dimension of force? MLT minus 2. Now, in this, mass is there, length is there, time is there. according to the system, what the system they are saying, according to that system, you will put the m value, you will put the L value, you will put the time value. So otherwise you cannot solve by taking the Newton. So Newton they given, so we know that SI system and MKS system all mostly quantities are same. So it means when they given the SI unit, then we will write the units in the terms of MKS. After that you will able to solve. This everybody got or not? Because suppose they said the Newton and dyne relation. So how you will apply? Suppose 10 Newton is equal to how much dyne? So N1 is the 10, U1 is the Newton. Then what is N2? You will get by the Newton and dyne relation. So what I said, we have to first convert. We have to write the dimension. According to the dimension, we have to put the value of mass, length, and time. Okay. So one homework I am giving, like you will convert the Newton and dyne. You will find the Newton and dyne relation. Newton is the MKS unit, dyne is the CGS unit. Okay, that is your homework. 1 or 2 question I will do here. Otherwise, Newton and dyne I can take. So convert 1 Newton into dyne. Okay, you know the relation also. 1 Newton is equal to 10 to the power 5 dyne. Dyne is the CGS unit. Dyne is what? CGS unit of force. And Newton is the MKS. Okay. So I am saying what? Convert 1 Newton into the dyne. Means I have to go from the SI unit to the CGS unit. So suppose SI unit I am taking 1. So N1 what I will take? They are saying 1 Newton. So what is the magnitude? 1. Okay. U1 is the Newton, but what I said, we will write first dimension. Dimension of force is what? MLT minus 2. Okay. Now M what I will put? Kg. What is the L I will put? Meter, because SI unit, MKS unit same, and T minus 2 I will put what? Second square. Okay. So this is the U1. Okay. So N1 1, U1 this. Okay. Second system they are asking the magnitude, then N2 means N2 they are asking. Okay. And U2 what I will write? U2 same, dimension will not change by changing the system, dimension will remain same. Now in the place of mass in CGS what I will put? Gram. In the place of length what I will put? Centimeter. In place of time what I will put? Second. Okay. Now we can apply the N1 U1 is equal to N2 U2. So 1 into kg meter per second square, that is equal to N2 into U2 is what? No, I think there will be no recorded. If you want, then later you can ask. Gram into centimeter upon second square. Okay. Now, if you will cancel the unit, then you will get the magnitude. So here I am using kg, here is the gram. So 2 options you have, you can convert this gram into kg or you can convert this kg into gram. Okay. Now kg, here I am writing as 1000 gram. Meter I am writing as 100 centimeter upon second square. That is equal to what? N2 into gram into centimeter upon second square. Now gram cancel out, centimeter cancel out, second square cancel out, and 2 what you got? 10 to the power 5. Then I can say what? 1 Newton is equal to 10 to the power 5 dyne. Completed. So this is the simplest. Okay, directly one MKS system to the CGS system I am going. Okay. Then, okay. Sometime they will use the hypothetical unit of system of unit. Okay, so one question I am giving. Convert 40 joule energy into system in which unit of length is 1 meter, mass 100 gram, and time 10 second. And second part, 1 unit energy in this system how much joule. Okay, so what I said here, suppose I am saying we have the 40 joule energy. Okay, the joule I gave means SI I gave. Okay, SI means MKS we can take. And we are going to the other system in which unit of length I gave 1 meter. Okay, that is no problem. Mass unit what I gave 100 gram. Mass unit 100 gram means not a gram. Means suppose I have the 200 gram mass, then how much unit of mass I have in this system? 2 unit. Means 100 gram we are taking as a 1 unit. So when I am writing the mass unit, what I will write? 100 gram. Okay. If I am saying the time, so time is what? 10 second. In the new system, in the hypothetical system, what is the time? Time unit is the 10 second. Means like maybe I am using any clock, in that 1 tick is equal to 10 second. After 10 second, 1 tick clock will give. Okay, like that in that system, unit of time what we are taking 10 second, and unit of mass what we are taking 100 gram. Okay, so that is any hypothetical atom. It is not the MKS, not the CGS, not the FPS. Okay, so we have to convert the 40 joule energy in the new system. Then what you will do? First you decide that, okay, one I will take as a SI, one I will take as a SI, and 2 I will take new system. 2 I am taking new system, 1 I am taking SI. Okay, so first joule is the unit of energy. So what is the dimension of energy? ml square T minus 2. Okay, then now first I will write N1 is equal to how much joule I gave? 40. So N1 is equal to 40. Okay, U1 is what? Joule I will write in MKS. MKS is what? Kg meter square per second square. N2 I want to find. Okay. U2 what I will put? U2 is what? In the place of mass I will put 100 gram. In the place of mass I will put 100 gram. In the place of length I will put 1 meter square, means meter square. Okay, and in the place of time I will put 10 second. 10 second means 10 second square. 10 second square. This everybody got or not? Mass unit is 100 gram, time length unit is the 1 meter, and time unit is the 10 second I put. Now solve it. N1 U1 is equal to N2 U2. So 40 into kg meter square per second square, that is equal to N2 I don't know, U2 100 gram into meter square upon 10 square means what? 100 second square. Okay, now to cancel the unit, this kg we have to convert in gram. So what I can write? 40 into 1000 gram into meter square per second square, that is equal to N2 into 100 gram into meter square per 100 second square. Now 100 cancel out, gram and gram here cancel out, meter square cancel out, second square cancel out. Now what is the N2 you got? N2 is the 40 into 1000, then you got 40,000. So N2 is equal to what? 4 into 10 to the power 4. This completed or not? Tell fast. Then after that, one more thing. Suppose I am asking, in this system 1 unit energy is equal to how much joule? Here the student do the mistake. I am asking 1 unit energy in this system how much joule? Okay, so when this type of problem is there, after that write one more line, then whatever they are asking you can decide. Okay, so one more line means what? Up to the N2 you got. Okay, now what I will do? N1, what is the N1? 40. What is the U1? Now I am writing joule because I already solved the problem now. N1 U1 is equal to N2 4 into 10 to the power 4. U2 new system. Okay, so if this type, like what is the second I ask, if this type of problem they are asking, so write this first. Okay, after writing this, then if I am saying 1 joule is equal to how much energy in the new system, 1 joule is equal to how much energy in the new system, then it means I need 1 here. So I will divide with 40 on both sides. I will divide with 40 on both sides. I will get 1000. Okay, so I can say 1 joule energy is equal to 1000 in the new system. 1000 in the new system. But reverse, if I'm asking 1 unit energy in the new system, 1 unit energy in the new system, then 1 unit energy in new system. If I need 1 energy in the new system, then it means here I need 1. Then what I will do? I will divide with 4 into 10 to the power 4 in both sides. Then what I will get? 40 upon 4 into 10 to the power 4 joule. That is equal to what? 4 and then 10. Then we got what? 10 to the power minus 3 joule. Then 1 unit energy in the new system we can write 10 to the power minus 3 joule. Understood or not? Completed. So that is a change of unit. Next class we will discuss about the round off, significant figure and all. No, all chapter will not be in the YouTube. Maybe next week maximum. Okay, wish you a very happy birthday, Nanita. Okay then, bye bye, take care.